Okay students, so let us continue with the concept on replication. So earlier we studied about the differences between replication and caching. So this was this slide. Now we move on to various advantages we can have. I think these points are very obvious, like increased availability, increased reliability, improved response time, reduced network traffic, improved system throughput, better scalability, and autonomous operations. So what happens is, since we have replicated files across the servers, there is a very good chance that the desired file may be nearby you or even in your own machines. So if it's in your own machine, that's the fastest way to access the file. Otherwise we can get it from the neighbors. So there is a very increased chance of getting the files in a very short amount of time. Then we come to file replication transparency issues. So replication transparency, what does it mean? So a replicated file server must function exactly like a non-replicated file server service, but exhibit improved performance and reliability, and multiple copies of a replicated file should appear as a single logical file to its user. So what it means is, if you look at your own file system in your own operating system, then you will find a single file existing in the server or in your machine. However, when you are keeping the same file in a distributed environment, you should have the same experience. You should feel like there is a single existence of the file, even in case of distributed computing. Okay, so though there may be replication behind in the server, still as a user you should be able to see it as a single entity, as a single file. Okay, so that reflects the replication transparency. Then naming of replicas. So in case of immutable objects, assignment of a single identifier is to all the copies of an object seems reasonable. Yes, because in case of immutable objects, you can only read the files, you cannot modify the files. So it is good enough to have a reference to a single replica of that file, because you know that it will not be changed, or if it is changed, then of course there will be a new version of it. So you just find out the latest version and then you get the file. Okay, so kernel can easily support this type of objects, so there is a very straightforward way of handling such kind of files. But in case of immutable objects, different copies of a replicated object may not be the same. Yes, because a file may be replicated, suppose 3 times, and in any of the replicas there may be a modification made by a particular user, and so there, in order to have consistency, that change must be reflected in all the replicas. Okay, so consistency control has to be there, and management of the various replicas need to be performed outside the kernel. So yes, of course there has to be a lot of management done in order to have same copies of that file. It should be consistent, the same content should be available in all the files. So if there is a particular change anywhere, then that must be reflected elsewhere. Okay, so it is more difficult to handle mutable objects than immutable objects. Then we come to replication control. Okay, so it includes determining the number and location of replicas of a replicated file. So as I told you, in case of Hadoop we have a default maybe value of 3 as a replication factor. But however, as a user, as a administrator, you can change the replication factor. You can keep it 5 or 10 maybe, according to your conveniency. So depending on whether replication control is user transparent or not, there can be 2 ways. So if the particular user is given the power to change the replication factor, then it will be one case, and if the user is not able to do, then it's a second case. So these are termed as explicit replication and implicit or lazy replication. In case of explicit replication, users are given the flexibility to control the entire replication process. So user has the authority to change the replication value. However, in case of implicit or lazy replication, the entire replication process is automatically controlled by the system with user's knowledge. So user actually knows about the replication factor. However, the system is going to keep control of the replication factor based on the performance of the entire network. Okay, so on what situations should the user be given the flexibility to control the replication factor? So it's a question I'm throwing to you. Just think about it. Okay, because if the user is given the power to change the replication number, then he or she may give a very high number, and it may cause a lot of problem rather than providing solutions. Because if you have multiple replicas, then if you make a change somewhere, you have to make changes everywhere, okay, in all the replicas. So things, and also there will be more amount of space required in order to keep more amount of replicas. So there may be certain issues, so it has to be controlled well enough. Then we come to this multi-copy update problem. So as I discussed, if there is a change in a particular file, then it must be changed in all the replicas as well. So there are various categories of replication, so it has been mentioned here. First one is read-only replication. So as the name suggests, you can only have or do read operations in a particular replica. So replication only for immutable files. So it is only convenient for immutable files where you cannot update or not update, I would say you cannot change the content of the file, so you can only read the file. So it is more convenient in case of immutable files. Since immutable files are used in the read-only mode, and because mutable files cannot be replicated, the multi-copy problem does not exist. So there is no problem in this particular scenario. You simply replicate it and you access them whenever you want. You can keep hold of only one of the copies, and that's totally fine. Immutable files cannot be replicated does not mean that immutable files can never be replicated. It only says that in this scenario where you have read-only replication, you cannot use immutable files, because in case of mutable files, because in case of mutable files you have to give the permission to change the content, isn't it? So read-only replication is only favorable for immutable files. Then files known to be frequently read. So I'm reading the last point. Files known to be frequently read and modified only once in a while, such as files containing the object code of a system program, can be treated as immutable files for replication using this approach. So there are various system codes we have, there are various code snippets we have that will never be changed, right? There is a very less chance of changing that particular code, so those can be treated as immutable files. Only once in a while changes may occur, and then a new version can be mentioned with the file, and there is no problem with that. So that particular concept is mentioned here. Then we go to read any and write all protocol. Okay, what does it say? Okay, it can be used for both mutable and immutable files. Then read any copy of the file, so you can access any one of them. That's totally fine. That's totally cool, because why? You are going to write particular change in all the files, because it is a write all protocol, right? It signifies that you have to write all the files, all the replicated files. So you can read any of them at a later time, and you will get the same content. So write all copies of a file. Locking mechanism must be used, of course, because when any one of them is getting changed, then you have to make sure that the other users do not see the outdated content. So there must be a locking mechanism. Then availability of a write operation is severely restricted, since all copies must be available for operation to complete the read operation. Okay, sorry, I think there is a problem here. The read operation is responsive since the nearest copy can be used. It's a separate point. When I give the slide, I will make sure that I make it a separate point for this particular line. What it says is the availability of a write operation is severely restricted. Okay, since all copies must be available for operation to complete. Okay, so it's a very tricky way of making changes. So you have to be very sure that write operation is done in a very safe manner. Okay, then we come to the available copies protocol. Okay, the problem with the read any write all protocol is that write operation cannot be performed if any of the servers having a copy of the replicated file is not working. So what it means is, if you have 5 copies of a file, that is, we have 5 replicas, then we have to make sure that all the 5 files are available at the time in order to lock maybe 4 of them and write in one of them. Okay, so the second point is allows write operation to be carried out even when some of the servers having a problem or a copy of the replicated file is down. So here it says that it is better than the earlier protocol, which said that you can read any file but you have to write all the files. But here we are saying that only the available copies need to be updated. Okay, so if there is a write operation, then you have to make sure that you have to make sure how many copies are available at the time, and then write all of them. So third point is, when a server recovers after failure, it brings itself up to date by copying from other servers before accepting any user request. So what happens is, if we do this, if we have maybe 5 replicas with us and one of them is down, then what we do is when the server is restarted, then it asks the other 4 users, or sorry, 4 machines, to give the replica back so that it is updated, because you don't know, right? There may have been certain changes made in the files when the server was down. So when the server comes up again, it is first going to get the latest update of the file and then only give this particular file to users if they request. Okay, so then we come to a primary copy protocol. So here, for each replicated file, one copy is designated as the primary copy and all the others are secondary copies. So it's like a kind of like a master slave concept where, you know, we rely upon the master for any changes. So read operation can be performed using any copies, so that's totally fine, but write operations are directly performed only on the primary copy. So whenever a write operation is required, you only going to access that particular file which has been given the permission to write. Okay, allows read operation in both. So in read operation there is no problem, but in case of write operation we have to have that master file available. Okay, how to tackle the write operation in this case? Okay, this is a question that I throw to you. So what will you do, like what mechanism will you use to make sure that you are accessing the primary copy? Suppose the server having the primary copy is down, so what do you do? So can we select a different master? Then can we select a new leader? So the question is to you. Then we come to the next concept, which is quorum based protocol, very important. Okay, so here certain rules has to be followed in order to execute read and write operations. So a read is executed as follows. So retrieve a read quorum. So quorum is like a group of entity, okay, group of copies here, any R copies of a file. So suppose there are n copies, you take R copies of them, and of the R copies retrieved, select the copy with the largest version number, because of course it can be immutable file also. So in those cases we are going to check the version and then we have to take the most updated one and perform the read operation on the selected copy. So it's very simple. You take R copies and then from that you try to find the most updated one and you use it for read operations. Then write is executed as follows. Retrieve a write quorum. So now we have W copies. So out of n copies you pick up W copies. Then of the W copies you take the file which is most recently updated, and then you increment the version, because here you are going to do write operations. So of course a new version has to be created because the older one will be deprecated, right? So a new version will be created and write the new value, that is the content and the new version number, to all the W copies of the write quorum, because you picked up W copies, right? So if you make any changes, you first have to change the version number, then give the content, new content or maybe modification, and then let the other copies know about it as well. So here we have 2 examples here. This is not a unified diagram. This is composed of 2 different diagrams. So suppose we have a group of 8 machines with us. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So here also we have 7 computers with us. This diagram is drawn to show you what a read quorum means. So and what a write quorum means. So in this example, in the left hand side, we have taken 4 copies as files to be read and 5 copies as files to be written. Okay, so here n is equal to 8, so total number of files that we will have is 8, and R value will be 4 here, and then W value will be 5 here. Okay, so whenever you make a read operation, you do from any one of them out of 1 to 7, 3, and if you have to do a write operation, take any one out of these 5 files, that is 3, 8, 5, 4, 6. Okay, so here you can see we have 3 involved here. So this is pretty important, because if you make any changes in any of these files, then of course you have to make the changes in all the files. Suppose you do a change in file number 8, then gradually or eventually you have to make this change available in 3, 5, 6, 4 as well. So here you see that 3 is also getting updated. So 3 is going to now announce them that the content of the file has been changed, and they will also do the same. Okay, so there needs to be a common party between the read quorum and the write quorum. So in the second example we see the same. Here again n is equal to 8, and then R is equal to 2 because 1 and 7 is 2, and then W is 7 because 1, 2, 3, 4, 5, 6, 7 copies are here. Here also we have a particular file which is also in the read quorum and the write quorum, because if some certain content has been changed, then this 7 will know it and it will inform 1 as well. So things remain pretty cool, right? So everyone remains informed about any changes. So as a summary, we have different types of quorum protocols. We have read any and write all protocols. So read any, so you can pick any one of them, so that's why R value is 1, but you have to write all the copies, so W is n. In the earlier case, you can see W was less than n, and here also W is less than n. However, if W is equal to 8 in both the cases, then it will become the first one, that is read any and write all protocols. However, I am also only concentrating on the write one. Okay, R value cannot be compared here. Okay, if you want to make this read any and write all protocol, suppose you want to make it a read any and write all protocol, then what will happen is maybe this one is in the read quorum and the entire cluster of files is the write quorum. Okay, similarly here maybe we can take one as the read quorum and all the files as the write quorum. Okay, so then we come to read all and write any protocol. So here every file will be read, so R will be equal to n, and since it is write any, one of them will be taken for the writing operations. So that is fine. So we will have to have a primary copy, and then we can always make changes in the primary copy, and then the others get to know about it. The third one is very important. It is majority consensus protocol. Here suppose n value is 11, then R value is 6 and W is 6. So what do you mean by that is, if you add them, 6 plus 6 is going to be 12, and 12 is greater than n, right? Or 12 is greater than 11. So what it means is that when you add the read quorum and the write quorum, they should be greater than the total number of files we have, and that will mean that there is at least one file which is in the read quorum as well as in the write quorum. Yes or no? Because if you take 6 files here and then overlap it with 6 files here, but total file is 11, it is not 12, so that definitely means that one file is getting shared in both the read quorum and the write quorum. So this is good, because if you make any changes in the write quorum, eventually it will be informed to the read quorum as well. Okay, and the last concept is consensus with weighted voting. So this is just mentioned here, you can go through it once, but my concentration is on step 3. In step 4, it means that all the machines will be given certain weight, okay, based on the importance of the particular server. Suppose a server is always in full time, always available, okay, always taken care of, then we will give higher weight to this particular machine, because those machines will be more reliable. So then we have to add the weights. Okay, so if the weights, if the collective weight is greater than the maybe a given weight, then we can have consensus with weighted voting. Okay, so here if all the machines are given the weight value as 1, then we actually talk about a majority consensus protocol, right? Because if suppose we have 6 plus 6, which is 12, should be greater than 11, so it's something like this. But however, in this case we assume that all the weights are equal to 1, but here we may change the weight values depending upon the importance of the particular machine. Okay, so with this I would like to wind up. We will again discuss in the next video. Thank you.